Good morning, everyone. In the last class, we discussed about the uh, cash flow diagrams and all these things. In today's sessions, we'll be dealing with the various interest formulas and all these things. Okay. In the last class, you studied all these things, okay, CFD. So, what is how to make all these things? In today's sessions, we'll be dealing with the simple interest calculations. Okay. So, simple interest, it is computed only on the original sum, not on the accrued interest. Okay. So, whatever the original amount is there, on that only we are going to calculate the interest. Okay, so it's a simple interest. Okay, total interest earned is p into I, it is small I into small n. Okay, so it will be the things. Okay, p will be the principal amount or the present sum of money. Okay, so I will be the number of interest and n will be number of interest period. Okay, so future amount at the end of n years, okay, at the end of 2 years, 3 years, okay, what will be the money due onto you? You have to pay the future sum of money. Okay, so that is given in terms of f is equal to p into 1 into 1 plus I into n. So here is an example over here. Okay, the company has a loan of 800 rupees is made for the period of 2 months at a simple interest of 10%. What will be the due amount at the end of periods? Okay, so answer it is there. Given data 800, the principal amount is 800 or the present money is 800. I is 10% and n equals to 2 months. That is 2 by 12 days. Okay, so ordinary simple interest f equal to p into p plus p into in. Okay, so interest plus principal amount. Okay, so here it is the total amount. The future amount has to be paid for the duration of 2 months. It is 893 rupees. Okay, by doing all the calculations, we'll get that. Okay, coming to next, compound interest. Okay, with the simple interest, the amount earned or the due money in one period does not affect the principal for interest calculation in the later periods. Okay, it's a simple. Okay, so whereas it is not practiced, whatever the thing is there in a simple interest is not practiced in the banking sectors or the other things. Okay, in practice we are going to see for the compound interest. Okay, for loan, whatever the loan is there, any interest owned but not paid at the end of the year is added to the balance due. Okay, it will be added to your principal amount. Okay, the next year is that interest is calculated based on the unpaid balance due. Okay, so which is unpaid interest from the preceding period, previous periods. Okay, the formula is like this. Okay, so f future sum of money equals to p into bracket 1 plus I to the power n. N will be the number of periods. Okay. So next we will be studying very important for the point of examinations. Okay, so there are 7 types of compound interest problems. Okay, single payment compound amount, single payment present worth amount. Third one is equal payment series compound amount. Fourth one is equal payment series sinking fund. Fifth one is equal payment series present worth amount, equal payment series capital recovery amount, and seventh one is uniform gradient series annual equivalent amount. Okay, in this today's sessions we'll be dealing with these things. Okay, So we'll be dealing with these things. Okay, we'll be studying 1, 2, 3, and this one. Okay, we'll be studying with these things. Okay, very important for the point of examination also. Okay, so these are the basic things. We are going to study these 4 kind of today, and later we'll be discussing the remaining things. So here the P will be of notations. P will be of the principal amount, N will be number of periods, interest periods, I will be the interest rates. Okay, it may be monthly, it may be quarterly or semi-annually or annually. So F is the future amount. Okay, at the end of year N. Okay, so A will be the equal amount deposited at the end of every interest period. Okay. Next is G will be the equal to uniform amount which is to be added or subtracted period after the period to or from the amount of deposited A1. Okay, at the end of year A1. Okay, at the end of the period 1. Okay, so this is the uniform amount. Okay, so next very first kind is of these things. Okay, single payment compound amount. Okay, very first here object is to find the single future sum. Okay, you have to find the what is the future amount. Okay, very simple. Of initial payment P made at the time interval 0 after period n periods of the 1, 2, 3 like this at the rate of interest I compounded every period. The formula is F equals to P into 1 plus I to the power n. Okay. So here is the example. Okay, find the compound amount of rupees 200 for 5 years at 8% compounded annually. Okay, so here it is. You have to find the future sum. Okay, use the formulas and all these things. Very simple formulas you have to calculate and all these things. Okay, so if we are putting all the data, present money is 200, the period is 5 years, amount is 8%. Find the compound interest. What is the future sum? Okay. So here it is for 200 you have to pay for the 293 rupees, 293.87. Okay. So next is a single payment present worth amount. Okay. So what is the present worth? Okay, if your money you are paying, what will be the present worth? Here is to find the present worth amount P of a single future sum. Okay, which will be received after the n periods at an interest of I compounded at the end of every interest periods. Okay, so here you have to find out. Okay, so formula for the present worth amount. Okay, which will be getting future sum. Okay, in order to get 50,000, what will be my present amount, present worth? Okay, so that kind of the formula is like this. Okay. This is the formula. P equals to F divided by 1 plus I to the power n. Okay, so you have to calculate all these things. Okay. So this is the one question. Anil wishes to have a sum of 50 lakhs, future sum of 50 lakhs for his daughter's tuition for a period of 10 years. Okay. So from now, what is the single payment that he should deposit now so that he gets the desired amount after 10 years? Okay. The future sum is FP here, it is 50 lakhs. If you want to get the 50 lakhs in the future of 10 years from now, what should he has to deposit? What amount he has to deposit at the interest rate of 12%? Okay, so this is the questions. Okay, this is all the given data. So n here over is small n. So putting all these things, he has to, I substituted all the data. Okay, the future sum is 50 lakhs. Okay, interest is 12%. 12 divided by 100 is 0.12, and the period is 10 years. Okay, he has to deposit the 6 lakhs 43,946 to get the deposit of 50 lakhs from now, 10 years from now. Okay. So here the main point, you have to draw all the cash flow diagrams. Very, very important. The cash flow diagrams are very, very important in this. Okay. You have to draw the cash flow diagrams. Okay. Third one is, so very important. Third one. So here it is a future sum. Okay. The objective is to find the future worth of n equal payments. Okay. Of n equal payments, A will be the n equal payments. Okay. If I'm paying the amount equally 5,000, 5,000, 5,000, 5,000 like that, which are made at the interest rate till the nth interest period of the 10 month or the 10 years. Okay. At the rate of interest rate. Okay. Compounded at the end of each interest period. Okay. So here the future amount, what will be the future amount, how to find the future amount if we are having the equal amount, paid the equal amount. Okay, so very, very important. Okay, so here it is, the formula is like this one. So we'll go here. Okay, so this is the formula. F equals to A is amount equally paid, equal amount has to be paid. Okay, so A into A plus I to the power n divided by I minus 1. Okay, so this is A for equal amount deposited. Okay, this cash flow diagram has to be shown in the your problem solutions. Okay, so very, very important. Okay. So next is the one kind of problems. The man is planning to build his own house. Okay, he divert his bonus amount. Okay, 40,000 as an investment every 10 years for now. Okay, he has invested the at the rate of interest of 12. Okay, find the maturity value amount for the 10 years. Okay, what is the future sum at every intervals of 4 years? Okay, if you have to find. Okay, okay, so A is the equal uniform amount he is paying of 40,000. The period is n, so n is equals to, it is small n, don't make it capital N, it is small n. Okay, so I is 12%, you have to find F. Okay, so this is the things. Okay, if I invested all these things, this is the formula you have to substitute. Okay, substituting the A, substituting the I. Okay, it is 12%, 12 divided by 100. Okay, it is 0.12. Okay, so to future amount is 7 lakh 1,949. The person will receive the amount after the 10 years if he invest 40,000 for next 10 years. Okay, so we'll be getting of 7 lakhs 1,949. Okay, so this CFD has to be shown in your problem solutions. You will be carrying more weightages. Okay. Next, very important in this we are going to discuss about in exam. Okay, in test also. Okay, so uniform gradient series annual equivalent amount. Okay, so what we do here. Okay, so object is to find uh, the annual equivalent amount. Okay, annual equivalent amount of a series with an amount A1. Okay, with an amount A1 at the beginning of the end of 1 year. Okay, at the end of first year. Okay, plus A1 plus with an equal increment. Okay, equal increment. Okay, A plus AG. Okay, at the end of each following n minus 1 years. Okay, with an interest rate of I compounded annually. Okay, so corresponding CFD will be like this. Okay, very important. Okay, here it is. The amount is of A1, and next consecutive years I'll be adding increment. Okay, G. Okay, 1G, 2G, 3G. Okay, so general formula A1 plus N1 N minus 1 into G. Okay, so this is the formula to find these things amount to be computed. Okay, uniform gradient series factor. Okay, so this is the things. Use this formula. So here next question, very important. A man planning for retirement, 8 more years of service. Okay, to deposit 80% of his salary, which is 15,000. A1 is 15,000 at the end of first years. Okay, thereafter he wishes to deposit the amount of increase. Okay, which is the G. Okay, G equals to he is going to pay off 2,000. Increment. The increment comes, you have to remember these formulas. Okay, just remember the formulas and get it with these things. Very simple problems. 7 years, the n is 7 years, n equals to 7 years with the rate of for 7 years. Okay, so I is 18%. 18%, 0.18. Okay, so what is the total amount at the end of 18 years? Okay. Okay, I told already. Okay, so this is the things. Okay, 8 years, what will be the amount? So the future amount he has deposited. Okay, A it is there, he has calculated. Okay, then equal amount. After this, the future sum of amount at the end of 8 years. Okay, so here it is 1. Okay, 8th year it is there. Okay, what will be the amount he is getting? So using this formula, which is the shown in your third. Okay, the two formulas are there. Okay, we have to use. Okay, so in that formula you have to use this one. Okay. So what is the A1? It is A1 plus G. Okay, so all these things, and he'll be getting the future sum of this much. Okay. So hope you understood this concept of this thing. And here one more thing is, you have this CFD is very, very important. Okay. Okay. So here we have to use this formula and this formula and get these things. Okay. Hope you understood this all concept, and for any queries, you feel free to contact me. Thank you.